I'm Mark Cyrus G.R. Sayong from grade 10 Bernoulli. And for today's video, we were talking about geometric series. What is geometric series? A geometric series is the sum of the finite and infinite number of terms that have a constant ratio between succeeding terms. In geometric series, we are supposed to find the sum of the terms of a finite and infinite geometric sequence. In solving geometric series, there are two formulas that we can use. One is for the finite geometric series and one is for the infinite geometric series. The formula that we were using in the finite geometric series is S sub n is equals to a sub 1 open parenthesis 1 minus r raised to the power of n close parenthesis over 1 minus r, and the formula we were using in an infinite geometric series is S sub infinity is equals to a sub 1 over 1 minus r. Let's proceed to our examples. Let's start with finding the sum of the term of a given finite geometric sequence. Example number 1. Find the sum of the first 6 terms of a geometric sequence 6, 12, 24 ellipses. The formula that we are going to use is this. S sub n is equals to a sub 1 open parenthesis 1 minus r raised to the power of n close parenthesis over 1 minus r. First, we're going to look for the given. In the statement, the given is 6. Our first term is 6. And the common ratio is 2. We get the common ratio 2 because of a sub 2 over a sub 1 is equals to 12 over 6 is equals to 2. And the term that we are looking for is 6. Let's find out what is the sum of the first 6 terms of this geometric sequence using this formula. S sub 6 is equals to our first term 6 in parenthesis 1 minus our common ratio 2 raised to the power of 6 over 1 minus 2. S sub 6 is equals to 6 open parenthesis 1 minus 2 raised to the power of 6 is 64 over 1 minus 2 is negative 1. S sub 6 is equals to 6 in parenthesis 1 minus 64 is negative 63 over negative 1. Negative 1. S sub 6 is equals to 6 times negative 63 is negative 378 over negative 1. So our S sub 6 is positive 378. Let's proceed to example number 2. Still, we are finding the sum of a finite geometric sequence. Find the sum of the first 7 terms of a geometric sequence whose first term is 3 and the common ratio is 1/2. Still, we're going to use the same formula that we used in example number 1. But first, we're going to look for the given. Based on the statement, our first term or our a sub 1 is equals to 3 and our common ratio is 1/2. The sum of the term that we are looking for is 7. So let's proceed. S sub 7 is equals to our first term 3 open parenthesis 1 minus our common ratio 1/2 raised to the power of 7 over 1 minus 1/2. S sub 7 is equals to 3 over 1 open parenthesis 1 minus 1/2 to the power of 7 is equals to 1 and 1/28 over 1 and over 1/2 because 1 minus 1/2 is 1/2. S sub 7 is equals to 3 open parenthesis 1 minus 1 and 1/28 is equals to 127 over 128 over 1/2. S sub 7 is equals to 3 times 127 over 128 is equals to 381 over 128 over 1 half. So our S sub 7 is equals to 381 over 64, because 381 over 128 divided by 1 over 2 is equals to 381 over 64. And now, we're going to solve example number 3. But this time, we're going to find the sum of an infinite geometric sequence. Find the sum of the term of the infinite geometric sequence 2, 2 fifths, 2 over 25, 2 over 125, ellipses. The formula that we are going to use in this kind of geometric sequence or series is S sub infinity is equals to A sub 1 over 1 minus r. But first, we're going to look for the given. As the statement say, the first term is 2, and the common ratio is 1/5, because A sub 2 is equals to A sub 1 is equals to 2 fifths over 2 is equals to 1/5. So let's solve this problem. S sub infinity is equals to 2 over 1, our common ratio, 1/5. S sub infinity is equals to 2. 1 minus 1/5 is 4 fifths. 4 fifths. And our S sub infinity is 2 divided by 4 over 5 is 5 halves. This is the sum of the infinite geometric sequence of this problem. And let's proceed to our last example. Still, we're going to find the sum of the infinite geometric sequence. Find the sum of the terms of an infinite geometric sequence whose first term is 5 and common ratio is 1/3. Still, we're going to use the same formula that we used in example number 3. But first, let's find out what is the given. Based on this statement, our first term or our A sub 1 is 5. And our common ratio is 1/3. So let's solve it. S sub infinity is equals to 5 over 1 minus 1/3. S sub infinity is equals to 5 over 1 minus 1/3 is 2/3. 2/3. And S sub infinity is equals to 5 divided by 2/3 is 15 halves, or 15 over 2. This is the sum of the example 4. And that's how we find the sum of the term of a given finite and infinite geometric sequence. Hope you learned something. Thank you and goodbye.